Okay, remember that in Algebra 2 and Pre-Cal you talked about log properties. I want to remind you of a couple of them. Natural log of 1 is 0. Remember, if you have a natural log that's being multiplied, you can split it into two logs being added. You can make this exponent come around front to be a coefficient, and a log with a division can turn into a subtraction problem. So as we go through this, when you're expanding your log expressions, you get the natural log of 10 minus the natural log of 9. Here, you're going to want to make this the natural log of 3x plus 2 to the 1/2 power, and then you can bring it around front, 1/2 natural log of 3x plus 2. Here, we've got natural log of 6 plus the natural log of x minus the natural log of 5. And here, this one looks pretty complicated. We're going to make this 2 the natural log of x squared plus 3 minus, and we need to bracket this because we're going to have more than one inside, natural log of x plus 1/3 natural log of x squared plus 1. We review those properties because those properties are the properties that are going to make taking a derivative of a natural log much, much easier to do. So, as we go through our notes, right here you have the derivative of your logs. Here's the natural log of u's derivative, which is u prime over ln of e times u. The derivative of a log that has a different base than e is u prime over ln a times u. And then when you are asked for an absolute value, it functions exactly the same as the one over here at the beginning. So we're going to practice. So right here, number 1, y prime. Well, here's my u. The derivative of 2x is 2, divided by, since this has a natural log, it's going to be divided by natural log of e, and then times the original u. Now, hopefully you remember from pre-cal that the natural log and e are inverses, so they reduce to 1. Then 2 over 2 will reduce, and your derivative will be 1 over x. Over here, y prime equals the derivative of u is 2x. It's a natural log, so you'll divide by the natural log of e times x squared plus 1. Natural log of e reduces to 1, so we'll get 2x over x squared plus 1. Here, the derivative of cosine is negative sine divided by the natural log of e and then u. Negative sine over cosine is negative tangent x. Okay, down here we have a log that has a different base. So the formula is exactly the same as the formula we were using earlier. We're going to get y prime equals the derivative of cosine is negative sine x. Now we'll divide by the natural log of 10, since that's the base, and then times cosine x. Now natural log of 10 aren't inverses, so it has to stay exactly like that, but we can still fix negative sine over cosine and get negative tangent x over the natural log of 10. Okay, here's where your log properties come in to help you, because this is a quotient inside a log and we don't want to do that. So before we start, we want to make this, we want to go ahead and expand it using our log rules. Then we have two fairly straightforward log problems. We've got the derivative of x squared minus 1, so that's 2x divided by ln of 5 times x squared minus 1 minus the derivative of x is 1, ln of 5 times x. Okay, what I want to see you guys do, I want 1 over ln of 5 factored out, and then I get 2x over x squared minus 1 minus 1 over x. And then if you're feeling really brave, you can get a common denominator, but you can leave it right now for me. Over here, I've got a product rule with my logs. So y prime, it's the first times the derivative of the second plus the second times the derivative of the first. So then y prime equals my natural log of e reduces, x over x is going to reduce to 1, so the answer is 1 plus ln of x. Okay. Turning the paper over, here I've got a chain rule, so I'm going to take the derivative of the outside, leave the inside alone, then take the derivative of the inside, clean up what I can. So on top, my numerator is going to have 3 times ln of x squared over x. You're going to have to do a quotient rule. You're going to do all the same things we've done before. The bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Ln of e reduces, t and t reduces to 1, so I get 1 minus ln of t over t squared. Okay, this one's a weird one because I got a natural log inside a natural log. So I take the derivative of the outside, leave the inside alone, times the derivative of the inside, my natural logs will reduce, so I have 1 over ln of x times 1 over x, and then probably we want to write it like this. Okay. Here, don't forget your rewrite. 1/2 log base 7 of x plus 1. So I do my derivative. I get 1/2. The derivative of x plus 1 is just 1. I get natural log of 7 times x plus 1. Okay, so I get 1 over 2 natural log of 7 times x plus 1. And can anybody figure out why I can write this to be 1 over the natural log of 49 times x plus 1? Here, do your rewrite. Y equals the natural log of 2x minus the natural log of x plus 3. So y prime is going to be the derivative of 2x is 2 over ln of e times 2x minus the derivative of x plus 3 is 1 over ln of e x plus 3. Ln of e's are going to reduce. 2's will reduce, so I get 1 over x minus 1 over x plus 3. Okay, here's a problem that looks really complicated, but if you'll take it to your rewrite, get your f of x. Okay, so I'm going to get natural log of x plus 2 natural log of x squared plus 1 minus 1/2 of the natural log of 2x cubed minus 1. Okay, so I take my derivative, I get 1 over ln of e times x plus 2 times the derivative of x squared is 2x over ln of e x squared plus 1 minus 1/2 2x cubed minus 1. The derivative is 6x squared over 2x cubed minus 1. Oops, and I forgot my ln of e. Okay, all my ln of e's reduce. So I get 1 over x plus 4x over x squared plus 1 minus 3x squared over 2x cubed minus 1. Okay. Now, let's talk about max and mins, tangent lines, and implicit differentiation. Derivative to get my max and mins. So I get the 2x plus 2 from a derivative of u prime, ln of e over x squared plus 2x plus 3. ln reduces. Remember, max and mins, I set my numerator equal to 0 and I set my denominator equal to 0. So on this one, my critical number is x equals -1. This one is actually no solution. In the real number system, you get imaginary numbers. So you come over here, x, f prime, and f, a critical number at -1. So I test either side, -2 and 0. Remember, I put it in my derivative. So I'm going to get negative and positive. So I'm decreasing and I'm increasing, so I have a minimum at -1, and then you plug it back up here in your original. So -1 squared is 1 minus 2 plus 3, so I get the natural log of 2. And just leave it natural log of 2. You don't have to worry about a decimal. Equation of a tangent line works exactly the same as it always has. Y minus blank equals blank, x minus blank. Made it easy on you. I gave you your x and your y, so 1 and 0. Remember, I need my derivative to go right there. So I am going to rewrite this and say y equals 3/2 natural log of x. When I take the derivative, I'm going to get 3/2 times 1 over ln of e times x. ln of e cancels, so I get 3 over 2x, and then I put my 1 in here, and I figure out my slope is 3/2. Okay, and the last one is your implicit differentiation. I'm going to do a rewrite for my natural log of x plus y. Okay, the derivative of the natural log of x is 1 over x. I took a little shortcut there. The natural log of y is 1 over y dy dx. The derivative of 5x is 5, and the derivative of 30 is 0. Remember, now I just want to get everything away from my dy dx, so I get 1 over y dy dx equals -5 minus 1 over x, and then to get y over there, I'm going to have dy dx equals y times -5 minus 1 over x. And then if you wanted to, you could get a common denominator. You could get a common denominator to finish off your problem. Okay, your assignments here at the bottom of the page out of the textbook. You need to work on that. This will be due in class on Tuesday. Don't forget you have your retest directions to work on, so y'all get busy. Have a good weekend.